static assignment, we select a topic that comes from our real-life example, which is seesaw. So what is static? Static is a state of linear and angular equilibrium. For example, when we have a seesaw in equilibrium state, it means that when an object is static, the sum of vertical force is Fy equal to 0, and the sum in horizontal force is Fx equal to 0. And the last one is the momentum at any point will be m equal to 0. So in this assignment, it's about the real-life example of static structure around us. So the topic involves a free body diagram, equilibrium, moment, and moment of inertia.
Hi everyone, so this is the seesaw. Now let's create a free body diagram from this picture. We can see that the center of the seesaw can be represented as the fulcrum, while the seats can be represented as the plane. The distance between two seats of 4 meters means that the distance between a seat to the fixed point is 2 meters. We can resolve the fulcrum into y-axis and also x-axis. Now we can see that in this system, the seesaw is in equilibrium state as there is no load put on them. But what if we put two loads on them, which is a person with 600 Newton on the right side and a person with 800 Newtons on the left side? Let's see what will happen. Now we can see that the seesaw will be tilted to the left as the person with 800 Newton is heavier than the 600 Newton. However, we also could see that the distance of them to the fixed point are equal. So now we will try to put the system of the seesaw back into the equilibrium state without removing the load. By doing this, we will maintain the position of the 600 Newton person, but we will adjust the position of the 800 Newton person to a new distance between the person to the equilibrium point. Now, we have to find the distance of x to find out what is the distance that should be put between 800 Newton person to the fixed point so that the seesaw will become the equilibrium state again.
Now, I'm going to continue on the second LO, which is the equilibrium based on the structure. As the structure, the seesaw, is in equilibrium state, all the summation of force and the summation of moment must be equal to 0. In this situation, we cannot include the force in x direction because all the movement does include the upward and downward direction. The summation of force in x direction is equal to 0, and therefore Bx is equal to 0. For the summation of force in y direction, we have Ay, which is 800 Newton acting downward. We have reaction force By, and we have Cy, which is 600 Newton acting downward. After all the simple calculation, we can see that the reaction force in B is equal to positive 1400, which is acting upward. For the summation of moment, I choose moment at B is equal to 0, and therefore we have moment at A plus moment at C is equal to 0. For moment A, we have positive 800 Newton because it acting counterclockwise direction, and the distance from B is x meter. And for moment C, we have negative 600 Newton because it acting clockwise direction, and the distance from B is 2 meter. After all the calculation, the distance for 800 Newton from B is equal to 1.5 meter. And I can conclude that the distance for 800 Newtons from the center of the seesaw must be 1.5 meter in order to make it balance.
Hi everyone, my name is Yin Ting, and I'm going to discuss about the calculation of the moment of inertia and the radius of gyration of the seesaw. Moment of inertia is a body's tendency to resist angular acceleration, which is the sum of the products of the mass of each particle in the body with the square of its distance from the axis of rotation. So now we are finding the moment of inertia with respect to x-axis, moment of inertia with respect to y-axis, and the radius of gyration of the seesaw with respect to both axes. So basically, the seesaw can be divided into two parts. The first part is the rectangular part, and the second part is the triangular part. The length of the rectangle is 4 meter, and the height of the rectangle is 0.08 meter. the length of the triangle is 0.4 meter and the height of the triangle is 0.6 meter. So first we need to calculate the rectangular part first of the seesaw. First we need to calculate the centroid of the rectangle. We are using V divided by 2 and H divided by 2 plus 0.6, where 0.6 is the height between the rectangle and the x-axis. V is the base of the rectangle, which is 4 meter, and height is the height of the rectangle, which is 0.08 meter. So we can get to 0.64 for the centroid of rectangle. Next, we need to calculate the area of the rectangle, which is base times the height, which is 4 times 0.08 to get 0.32 meters squared. Next, we calculate the moment of inertia with respect to x-axis. We are using 1 over 12 bh cubed plus ad squared. B is the base of the rectangle, h is the height, and a is the area of the rectangle, and d is the distance between the centroid and the x-axis. So we can get the answer of 0.1312 meter to the power of 4. Next, we can calculate the moment of inertia with respect to y-axis with the equation of 1 over 3 hb cubed. H is the height and b is the base. For the triangular part of the seesaw, we can first calculate the centroid, b over 2 plus 1.8. 1.8 is the distance between here and here. Okay? And h divided by 3. H is the height of the triangle to get the centroid of the triangle, which is 0.2. Next, we need to calculate the area of the triangle, which is 1 over 2 bh, b times h. B is the base of the triangle and h is the height of the triangle. For the moment of inertia with respect to x-axis, we are using 1 over 12 bh cubed. Again, b is the base of the triangle, h is the height of the triangle. So we can get this answer, 7.2 times 10 to the power of negative 3. So now we can calculate the moment of inertia with respect to y-axis, which is 1 over 36 hb cubed plus ad squared. A is the area of the triangle and d is the distance between the centroid of the triangle to the y-axis. So now we can find the total moment of inertia with respect to x-axis and y-axis. We are summing the rectangular part and the triangular part moment of inertia with respect to x-axis to get this answer. Now we can calculate the radius of gyration of the seesaw with respect to x-axis. We are using the equation square root of moment of inertia divided by area to get this answer. Next, we are calculating the radius of gyration with respect to y-axis using this formula, which is square root of moment of inertia with respect to y-axis divided by area. Area over here is total area of the seesaw, which includes rectangular part and the triangular part. So we can get the answer of 2.2299 meter for radius of gyration.